Here we have a little bedside light. The idea is you're supposed to tap this and it's supposed to dim. 3 different settings. As well as that, you can charge up USB-A and also what looks like USB-C. And it is currently, they sell loads of them. Look at the amount of reviews. 1,000 have been bought in the last month. And it is £15 at the moment, down from $20.99. So this one looks like it's all wobbly at the top here, so I'm just going to quickly take that bit apart, see if it slots back into place. We'll get a light in, we'll see if it's working. It might be that this has just come out here and it just needs to be put together properly, or maybe the touch or the charging's not working. Alright, the plastic's a bit broken, so that doesn't clip into place, but I'm plugged in and nothing's happening when I turn it on or off. I don't know which way is on and which way is off, but nothing's happening there. Nothing's happening here on USB-C. When I do it that way there, nothing's happening. And if I plug it into USB-A, we still have nothing happening. And it doesn't make a difference. Touching this, it doesn't turn it on. So I think we do need to try to take it apart. I'm wondering if this here is faulty, because we don't seem to have any power, and to me it feels a little bit rattly. Let's bring it over to the mat and see what's what. Let's see if you can hear the rattle. I know it's rattling everywhere, but it does sound like there's a bit of plastic loose in that. First things first. Make sure the fuse is alright. 13 amp. 13 amp seems a little high, even though it's got the charging on it. Fuse is alright. So now, annoyingly, that was it. I really heard it then. Hopefully you can hear that. This is all moulded shut. So that's not really an option. I think I need to get in here, and then I can measure it from in here. So let's see if this will peel back. Yes, it will. Right, so this isn't wood, it's just some vinyl sticker. And that came off very easy. Is that going to pop out or not? There we go. Oh, does that look a bit burnt here? That looks burnt, doesn't it? Well, first of all, let's check. At least we have access now. We might not even need to get in here. Let's check from here. Let's put this back in. Check from here right the way into here. So let's go on to neutral, which is here. Neutral. So that's okay. Now let's go on to the live, which is here. Nothing. Turn it here. Ah, so it's not this. So good job, I didn't take that apart. So you can hear now. Right, so let's leave that on there. So it goes into this ball. Ah, I can see a burnt resistor. Look here. That's where the black mark's from. You see that burnt resistor here. Right, so we need to get this cover off and see what's happening. Maybe that is acting as some sort of fuse. But you can see it's well and truly burnt and it's gone right the way up there onto the blue. Not quite sure how that would have happened. So this is a massive heat shrink on it. Ideally I need to take this off completely, don't I, so I can see the whole circuit. Alright, here we go. Cut that as well by accident. Now, Yeah, F1 fuse 1. Has something caused it to go? I wonder, has the bridge rectifier or something failed? So that's the bridge rectifier there. So the live comes up and it goes from here to here. So we're not going to have anything going into the bridge rectifier. So from the neutral, it goes to here, which goes into the bridge rectifier here. But the live will go to here, but it's not going through to here, this one here. Right, let's go to diode test and see if the bridge rectifier is okay. The rest of the components look alright, but what caused the fuse to blow? Do you know what I think's gone? I'm wondering if these got shorted in here or something, because if you have a look from the top here, you have the white and black wire feeding this light, and the white goes straight on to the neutral from the plug. So the neutral from the plug will be going all the way up into here, and I presume it's going to be this one on the edge. Yeah, but the live, which is the red one, goes to the board here. And if you have a look at this transistor, it's got a big hole in it. So I think that blew, which took out the fuse. And maybe that blew naturally. That looks like an inductor. Maybe that blew naturally, or maybe somebody accidentally shorted it. So let's give it a clean up and see if we can get any readings. See, it says TR1. I'm not sure if we're going to be able to get any readings off it. In fact, I can unsolder it, can't I? Because it's marked on the board that the flat side goes here. And also, I need to try to work out what fuse that is. Black, gold. Maybe gold again. Black, green. Silver? Green, I think. Right, okay. Let's give everything a clean up. Now, we'll get back to this bedside light in just a minute, but let's have a quick word from today's sponsor, PCBWay. Now, if you're into tinkering, repairing, or making your own projects, PCBWay can help turn your circuit ideas into proper professional boards. Now, check this out. PCBWay currently have 60% off flexible PCBs. The advantages of having a flexible PCB is it has excellent flexibility, so you can fit it where you might not be able to fit a rigid circuit board. Also, you've got space and weight savings. They're very durable and improved heat dissipation. And you don't just have to have single layer flexible PCBs, you can also have double layer and also multi-layer flexible PCBs. So if you fancy building something that bends but doesn't break, check out PCBWay. Links are in the description down below. Now let's get back to this little bedside light. Let's give everything a clean up. Got some isopropyl alcohol. So I think the transistor might have blown because maybe it was faulty from manufacture and then took out everything else. I don't need to worry about these caps here because it's not going through the bridge rectifier to charge up the caps because the fuse is gone. In fact, what causes the touch sensitive bit on here? When you hit the base or hit this? Unless this one isn't. Maybe this one isn't touch sensitive because the other ones were round. But they had the same number at the bottom here. This model number. Maybe it's something to do with this ground here. Now that's just for safety, surely. I don't know. As always, it's a mystery to me. I've never worked on a touch lamp before, so I don't understand how they work. Anyway, I'm going to unsolder this fuse and also this transistor thing as well. I just want to see if there's still continuity through the inductor, or has that been blown open? Yeah, so there's still there. So the inductor then goes up to the red one here, which goes up to the black and goes up to the actual light bulb itself. So that transistor is on the AC, isn't it? Which is going straight up to the light from here. So it looks like from here it's going across to feed the rest of the circuit, probably via this switch here. But it goes straight up to the light. So from here, it looks like when the base is enabled, because I wonder, is that getting enabled through here, through this chip maybe, to the base here? It then will connect this to this, which will then go through the inductor and liven up the red one here. And remember, the white from up here is already connected to the blue. So we've already got the neutral going up. So I think that's what's happening. So I think the transistor failed, which then took out the fuse. So what we're going to do is, let's just go to diode test. Let's just see if the bridge rectifier is still okay. So nothing there. Something there. Nothing there. Swap that over. Something there. I think that's okay. I think that looks all right. Doesn't look like we've got any shorts. So we have to try to find out what the fuse is and what the transistor is. So let's zoom right away in and see if it uncovers any of its secrets. Annoyingly, it's going to be burnt right the way through there. Maybe I'll have to look up about switching a touch sensitive lamp and see what it is. So I suppose once you touch the base, the thing I don't quite understand is what's detecting the touch on the base? Is it via that ground here? Because once we touch this, that is going to be in contact with this ground here, and it goes to here, goes through a safety capacitor, and then I presume works its way into one of the chips. So by me touching here, am I? Well, now I'm going to be enabling the chip, aren't I? Which is then, because there's going to be different light settings like low, medium and high, I think. And then it's this which is going to be turning on this here. So yeah, I'm not sure how I'm going to find out what that is, because that looks like it's been blown right the way in the middle. Yeah, you can see there's no markings left on it, unfortunately. And what we got on the fuse. Right, there we go. At least we've got the markings here. Green, black, silver, gold, black, or maybe it's this way around. Black, gold, silver, black, green. All right, let me do a little bit of research, see what's what. Well, I've definitely found the one here, not quite as popular, only 100 bought in the last month, but that's got the square base, and it is a touch control bedside lamp. A little bit more expensive as well, $16.99. Well, we know by having a quick look at the circuit that it's coming from the AC. So this transistor thing's connected to AC. And I looked up the difference between a transistor and a triac, and transistors are used for DC circuits and triac switches are designed for use in AC circuits. So it looks like this must be a triac, because when I look at my transistors here, you know, like a multi-purpose one here, the voltage is not AC voltage, is it? So it's way too low. So it looks like what I actually need is a triac. I think this might be a bit troublesome to find out what I need to put in. Right, having a look, it's not that straightforward. I've had a look through my transistor kits and I haven't got any triacs in. As far as I know, these are just transistors, but I haven't typed in every single one of these numbers, but you can see PNP, NPN, etc. on each of them. So I don't think there's any triacs in there. I don't think I've got any triacs, which is a shame. Mostly when people try to repair them, they're just changing out the module, because you can get touch lamp modules quite cheaply. In fact, you can convert your own lamp into a touch module, I think, from inserting one of these in. And you can see that this black wire here would be the one that you would touch in order to switch it. So it would probably be possible to leave this as it is and put a new fuse in or a new resistor in here to get these ports working, and then you could get your own module, and as long as you could fit it in here, which I think you could, then you could just wire, you'd use the black one here as the ring up here, or you could splice this wire here onto the black one and then splice in the live and the neutral, and I think you're going to have it working as well as this one here. Anyway, I haven't really thought about how you would wire it in, but I think that would be possible. But I think this is the one that I need here, a Triac BT131, because if I go here, there's one on EV blog, and it's saying that it's his daughter's lamp that's not working. This is done by Spike 1947, and it's one of those ones where you hit 3 times. And when I look up the Amazon reviews here, that's what you do: dim, medium, bright, off. Yeah, or you touch here. So in fact, looking at it here, I don't even know unless this is metal here, which it might. It doesn't feel like it is. Let me just see 1 second if that's metal, because maybe this one only works if you touch this here. Yeah, maybe you have to do it by touching this here. So it looks like it's the same one, but yeah, on this one here, the triac's also gone, and it's saying it's this triac here, BT13109H triac, and they're saying why it might have failed, and it could be from using a CFL lamp, which will kill it from the current spikes, or maybe a lamp that was too big. So maybe that's what's happened here. Rather than having a small LED lamp in it, or a low voltage incandescent, maybe a low wattage incandescent, maybe they did have something that was too powerful for it, and it just burnt out the little triac, because the triac is absolutely tiny. Most of the triacs that you see, they look more like MOSFETs. They're big things, you know, not this tiny little thing here. So, but look in here, it's saying 0.6 amps, but that's got to account for this as well. So that's not much watts, is it? Because if it was 1 amp, it'd be 240 watts. So 100, so that's going to be 1 second. So that would be 24 watts times 6. So you're looking at, you can't put a 150 watt lamp in, because this also has to power these as well. So maybe it is designed for something just like, you know, like well, what realistically, what are you going to put in there? You're not going to be putting more than 60 watts in there anyway. So yeah, I think that'd be right. Maybe it was a CFL that killed it, as this one said here. So yeah, I need to look up to see if I can buy one of these, but I don't want to spend too much money, because it's not an expensive item. And also we have this broken here, so you can see that we have plastic here and here, and it should have little clips coming up. These should go up higher, and this should sit down in it here. But I mean, I could glue that in, and I could just pull those wires down there. In fact, is that coming up there? Yeah, that's going up there. So I could just pull them down and maybe put a bit of hot glue, and that then it won't want to lift up then. So I think it is going to be repairable. Now it looks like they are dirt cheap if you go to one of the bigger companies like DigiKey. 7p each. That's crazy. It goes down to 0.46p if you buy 10 of them, so 46p for 10 of them, which is amazing. It's just that I have to spend £33 on delivery, which I don't want to do, so I think I'm going to have to buy them on eBay. But you can see here 600 volt, because they're AC, so they're going to be switching on both sides, and so I don't think 240 volt would be enough. And the trigger is 1.5 volts, so I suppose that tiny little thing here must be just out. When you touch it, it must be out in 1.5 volts to the middle pin here, which is then telling this to I don't quite understand how the dimming side is happening. Is this also controlling via here? Is this also controlling that as well? From there? No, because that's coming straight from there. Yeah, I'm not quite sure how the different brightness is happening, unless, for example, if you were to put 0.5 volts onto the gate, would it be a certain brightness, like dim? 1 volt would be medium, and 1.5 volts would be like fully on. Is this controlling? I suppose the gate must be controlling how much it is being turned on. It must be, mustn't it? Yeah, and that's doing that, I think. So yeah, annoyingly, although they're really cheap, I think I'm going to probably have to pay £2.50 for one of them on eBay. I wouldn't mind some more. Now we know that this is marked up as a fuse, and it makes sense that it's a fuse in the position it's in, and it's clearly marked up as F1. But fusible resistors have a white band at the end, and this hasn't. I'm not sure which way around it goes, but it's either green or black. So I think it is just a normal resistor and not a fusible resistor. So 1 watt resistors are normally 12 mil, but this isn't. So I think this is half a watt. And if I use AI here, it says 9 millimeters long by 3.2. And I can see that that is 9 mil there. And that does look to be about 3-ish mil. So I think I need to get a 0.5 watt resistor. I just need to find out the markings now. Well, like anything, confusion is just caused. It's a 5-band resistor, but which way do you even read it? So you say to yourself, okay, well the biggest gap is going to be at the end here, but it still doesn't make any sense. So let me zoom in. I've looked up 5-band resistors and that doesn't seem to make sense. But when I look up 4-band resistors, it seems to make more sense, even though it's got 5 bands. So let me zoom in. We know it's not a fusible resistor because it hasn't got a white band at the end, unless maybe a black band means something else. But if you have a look here, there's definitely a bigger gap there. And also the green is closer to this side. So it looks like green is number 1. And I think that gap is smaller than that gap, because if you have a look at the nib of the pen there, or the ball at the end, can you see it doesn't fill the gap? Well, this one does. So I would say it's going to be green, black, silver, gold, black. Now, green is going to be 5. Black is going to be 0, but then there isn't silver. It's grey, but that's silver to me, not grey. But let's say if we think it's grey, then it's going to be 508, and then gold here is divided by 10, and that would equal 50.8 ohms. But then if we were to use, which seems quite big for a fuse, but then if we were to read this one here, which is a 4 one here, then it would be green, which is 5, black 0, and then it would be silver here times 0.01. So it would be 50 times 0.01 is going to be 0.5 ohms, which sounds better. 0.5 ohm resistor. Well, look at this. I typed in 5-band resistor as a fuse, green, black, blah, 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 blah. And it says here, green, black, silver, gold, black 5-band resistor is a 0.5, which I thought it would have been if I was reading it from here. Fusible resistor with a tolerance of plus minus 5%. It's designed to act as a fuse in a circuit burning out at a certain current, and the last black band may indicate it's a wire wound type or a special marking for fuse application. See, I read that it was supposed to be white as the last band. Now, it is AI, but that might be correct. Do you know what I'm going to do? I'm going to use Google Lens and take a picture of it and see if it says what it is. This is it here. This is the same one. Yeah, green, black, silver, gold, black. Read it. Samsung TV power board. Looks like a 50.8 ohm. Oh, then it's correction. It's a 0.5 ohm because it's a 4-band resistor in disguise. There you go. Yeah, 0.5 ohm. So I think I need a 0.5 watts, 0.5 ohm fusible resistor. It's confusing, isn't it? Because you think it's a 5-band, but it's a 4-band in disguise. Okay, I've been ordering from AliExpress. I'm just about to buy these. I've gone for the bulk lot because apart from the time it takes to arrive, I will get a lot more than if I bought from eBay. So these are $125 plus $199 shipping for 50 little triacs, and I'm getting 50 of these as well. Not that I need that many, but it's always useful to have spares, for 77p and £2.50-ish postage, and it's going to be half a watt and 0.5 ohms as well. And I'm treating myself while I'm here to a pack of 1 watt resistor kits. So there's all different ones there for £5.49 plus £2.71 postage. So altogether £14.67. So once it all arrives, we can pop them in and see if this starts working again.
A week and a half later.
Well, it's a little bit later now, and all my AliExpress spares have arrived. So I've got 50 of these little triacs now. It says here, BT131600, Triac 600 volts, 1 amp. So hopefully that will be okay. And I've got my fusible resistors here. Again, 50 of them. So this will probably last my lifetime. Half a watt at 0.5 ohm. And then I treated myself because while I was ordering stuff, I thought I might as well. Can you see these are bigger? I've got some 1 watt resistors. These are a nice bit bigger here. And I've got all different resistances. So again, hopefully that will come in useful in the future. So let's pop in one of these and one of these, and let's see if it comes alive. Well, this is going to be nice and easy to do because they're through-hole components. So I just put the resistor in, fusible resistor. Also, one of the wires comes out when I do this as well. In fact, 2 wires come out when I'm doing this. When it comes to the Triac, I just want to measure with my multimeter to see if the new one is measuring differently than the old one. Right, so I'm on diode test. On the old one, they're both on the flats with the curved bit here. So if I go on to the middle one and this one here, we have a full short, and this one here we have nothing. So full short there, nothing. On the working one, we got nothing there. And a reading there. Swap the leads over, nothing there. And a reading there. So you can see that this is shorted here between these 2 legs, yet this one isn't. Right, let's pop that in. So let's just place this Triac in. You can see on the board it says TR1 next to it, so I should have known it wasn't a transistor, because although TR sounds like a transistor, it's not. Transistors are normally Q, so it might be like Q1 or Q2 or Q3, while this is TR. So I should have known that it wasn't a transistor, but it can be a little bit confusing when you see TR, you automatically think it's going to be a transistor. But no, TR, I presume, must mean Triac. So again, I need to remember that for future. While I'm popping this in, let's give a shout out to the My Mate Vince Massive. They are the top level Patreons. The members this month are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pigsy, Anthony Dean, Russ Melanson, Ricard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, and AJ Computer Services UK. So massive thanks to everybody that supports over on Patreon. Now we are ready to turn this on. So LED, so at 4 watts this shouldn't be blowing up. That's Triac. This will have to be glued down into place, but hopefully that will be all right there. So I'm going to leave it down on here, so if it blows up it's not going to go in my face. Right, here we go. I'll turn it off for the moment. Is it going to go bang? I mean, this shouldn't be exploding in my face anyway, should it? Right, here we go. Plugging it in now. I'm just going to get out of the way a little bit. Ready? On. Oh. Well, that was annoying. It gave a little flicker, didn't it? Surely it hasn't blown already. Maybe it has. Should we give it another go? I think it might have blown. Oh. Oh, what's going on? Is it flicking or is it when I do it? Maybe it doesn't work with LED lights. Well, it's definitely doing something. I'll tell you what we're going to do. Let's get this here and see if this lights up on the USB. Right, so oh, it's there. Did you see it was on there for a minute? So let me just carefully turn it on. Yeah, so that seems to be working. I think it might be a problem. I'm going to unplug it. Maybe it doesn't like the LED thing for some reason. Let me see if I've got any incandescent anywhere. Oh, I've had a look and I haven't got any incandescents because everything I've got now is like LEDs. So we're back to this one I tried at the beginning of the video. This is going to draw a lot more than this. What I'm thinking is maybe this is so weak that it's not even being registered. There's not enough sort of drain on this to get this to latch on. So I'm going to try this, but these are the things that I think cause it to fail because of the spikes according to that little you know, the forum earlier. Let's just see what happens now. Maybe this one will latch on, in which case then we know if we get an incandescent one, it will be all right. Right, here we go. I'm plugging it in now. Again, standing away a little bit. Right, turn it on now. So it didn't flicker there. This thing down here is on. Oh no, it's not working. Ah, it's not working. What? I don't think I know how to fault find that anymore. Should we see if the track's shorted? Doesn't appear to have shorted. We know that power's getting to here, so the fusible resistor is okay. Should we have a close look again? Let's just make sure I'm not going to get a shock off anything. So let me just measure this cap here. 14 volts, that's all right. 13 volts, that's fine to work on. Let's have a quick zoom in, just in case maybe that resistor, I don't know how it latches on. I presume it's that chip. So the triac is only turning on for a couple of seconds. So it recognises when I touch it, but it's not latching on. It needs to go from there to there. So if I was just to put a wire from here to here, then it would be on all the time, because we have the negative from here, or is it the positive? No, the AC, sorry, the AC from here going up the wire here, the blue wire, straight to the light. And then from this one, it goes through here, and it should get switched to here, go through the inductor and then on. So if I was to go to here, the light should just be on all the time. So why is it not latching on? Should we measure these resistors? I'm just going to shout out what they are. So this should be 10,000 ohms. Right, this is 0.377 k ohms, so 377 ohms. So that's quite a bit different than 10,000. This should be 220. Oh, this is also 0.33. Maybe if you were to put those two next to each other, then that's what they're going to equal. So that goes through here, Just make sure there's no short there. That's in the meg ohms. So this should be 10. This should be 100,000 ohms, and it is. And then from here, where do you go to? Which leg do you go to? Right, so that comes up on that leg there. Second one there. I mean, the chip might have failed. I think I'm going to just slide these two off just to make sure they are reading what they should be reading, because maybe they got a bit burnt out. You know what? The board's moving around too much. I'm going to use a soldering iron and some low melt solder. It's so much easier. Right, this one should be 10,000. And it is. This one should be 220. Wow, that's where we were getting it from. This one's gone. So if you have a look at 103 is 10 with 03s, which is 10,000. And you can see there 9.8, so 9,833. But this one is 221, so it should be 22 with 10. And it's coming up as 379 ohms. So it is 159 ohms more than it should be. That's correct, isn't it? Yes. So that means it's not quite, but it's almost twice as resistive as it should be. So maybe that's where the problem is. If we've already got quite a small voltage coming through, maybe by having the higher resistance here, it's enough for the triac to not be getting the signal properly. And that's why on the LED, it's making a slight difference when I touch it, but on the other lamp, it wasn't making any difference at all. I don't think this triac's being turned on properly at all. So let's get a 220 ohm resistor in place, and let's see if it starts working. Right, my resistor kit from eBay, 220 ohms, this one here. Take one out, and we'll just measure it out a circuit to show you the difference. So you can see on the new one, it's down as 222 ohms, so 222 ohms. It's marked up as 2200, but that is the same as 221. And if you have a look here, the old one is 369 ohms. So you can see there's a big difference between them. So let's get this new one in that's marked up as 2200, which is the same as 221. Well, you know, it is a lot different, isn't it? 220 compared to like 340. But I'm just not sure whether that would be enough to actually cause the failure of it. Let's see. I'm going to go back to the LED one. Again, plug this in here. Right, here we go. Plugging it in now. Turn that on. Right, we've got life down here. Yes! Yes, yes, yes! Fantastic! Oh, lovely! And off. Maybe this doesn't have different stages of brightness, it's just on and off. Does it work if we touch it here? Oh, it works here. How is it picking up my finger when this is plastic here? How is it picking up my finger there? Oh, look at that. Oh, it looks lovely. Fantastic. I'm going to get my phone, plug it in here, and see whether it's going to draw anything. Yes. There we go. Charging. Yeah, 1.8. I don't want to overdo it. 1.8 amps there at 5 volts. 1.9. Fantastic. And it comes on here. I don't want to overload it, but this is low here, so I'm sure it can cope with both of them. Oh, what a result. And then when you turn it off, nothing happens. Right, okay, really happy with that. So, triac, fusible resistor, and the tiny resistor. Out of all of them, I like the tiny resistor more because it pretty much looked perfect. Right, I'm going to put this all back together and put the, I'm going to put a tiny little bit of glue just to get this in here, a little bit of epoxy, and just put it down there and down there to hold that into place. And then I'll show you at the end with all the bottom back on and everything like that. So it goes together really nicely. I mix up some epoxy and I just put it down on the two bits that would have originally had clips, and then I just force this down into place. I pull the wires going up to feed the lamp a little bit tight, and then I put a cable tie at the bottom just to lessen the chance of the top falling off if the epoxy was to break, but then they're not under strain. And then I just put the heat shrink back over the whole thing, because obviously this needs to be insulated because you're touching it, and if the live side was to touch the lamp casing, then there's a risk of electrocution. So I put the heat shrink back on and I tape it up with some electrical tape so it's not going to come undone. And then I put the plastic back in the bottom and I put the foam back on. It looks brand new by the end of it. So yeah, let me now bring it into the room. Also, the touch dimming is working, but it works differently than I thought. Right, here it is in all its finished glory, and it's come out looking perfect. It looks brand new and it's working an absolute treat. So turn it on here, and then it doesn't matter where you tap it on the base, even if you touch it very gently here, it's going to work. So there must be some kind of metal underneath this coating here to recognise the touch. So as a bedside light, that would be quite nice. Rather than trying to feel this in the dark and then working your way up to here, you can just reach over and tap it and then it will come on here. And guess what? It does dim, but it's not like 3 taps. You hold it down and then it will dim up and dim down. But this LED bulb here, which is lovely, is not dimmable. It says on the box here it's not dimmable. So I have one of these old Osram ones here, which I presume is just incandescent. This one does dim. So check this out. I'm just going to swap the bulb over, or the lamp I should say. Now this one doesn't look as nice, but it dims. So if we turn it on here, and it remembers the setting. So turn it on. And you can see right now, that's very low. Watch this. If I hold this down, it will get brighter. So hold it down. There you go. Can you see now it's brighter? And I think it will go a bit brighter than that. Hold it down again. And what's that? That's getting dim. Hold it down again. There we go. So you can see it's kind of linear. But it's not that intuitive. But the idea is you would set it to the brightness you like, and then it remembers it. So every time you turn it off, and then back on again, it should be at that setting. I don't know if it will remember it if you were to unplug it though. And if you want it dimmer, just hold it down, let it go dimmer like that, and now it will remember that setting. You know what? I thoroughly enjoyed that video, way more than a 15, 16, 17 or 18 pound item would have you believe. I really enjoyed it, and I learnt a couple of things. I learnt that triacs are an AC thing, not a DC, and also that I'm even more confused about fusible resistors. But yeah, I really enjoyed that one there, and the icing on the cake was swapping out that little resistor at the end to get it to work. So if you enjoyed this one, give it a massive thumbs up, and I will see you hopefully again very shortly on another Fix It video. Love it.